All right, this is our very last example. A small plane can fly 350 miles with a tailwind in 1.31 and 3/4 hours. So we're going to use 1.75 because that'll be easier. In the same amount of time, the same plane can travel only 210 miles with a headwind. What is the speed of the plane in still air, and what is the speed of the wind? So we know we have uniform motion, so we're going to say rate times time equals distance. Now, we have our distances. We have 350 miles and 210 miles. We can put those in right away. Okay, in the same time, so what is my time? It's 1 3/4. So I'm going to use 1.75 for the time. And let's let P be the speed of the plane in still air and W be the wind speed. So if it's going with the wind, then the plane is going P miles an hour and then the wind is pushing it to go faster. So the rate with the wind would be this P plus W because the wind is making it go faster. Now if the plane is flying into the wind, it's going slower. This plane is trying to go P, but the wind is holding it back. It's blowing against the nose of the plane. So it's P minus W. Now, since I have already used two variables, I don't want to use variables anywhere else in the problem. And we don't need to because all the other numbers are given to us. So my time is 1.75 for each. It's just easier to work with than 1 3/4. And my distance would be 350 with the wind and 210 against a wind. Now, when it says 350 miles with a tailwind and 210 miles with a headwind, you may not know exactly which one is going with the wind and which one's going against, but if you think about it, it's going to go further if the wind's helping it. So put 350 with the P plus W. And it's not going to go as far if the wind is hurting it, so 210 goes with the P minus W. Now what equations do I have? Good, rate times time equals distance. So we have rate, that's my P plus W, times time, times 1.75. I want that P plus W in parentheses because I'm using the whole thing as my rate, not just part of it. Then I'll have rate times time equals distance. And before I decide which method, I probably want to distribute that 1.75. So P plus W times 1.75 would become 1.75P plus 1.75W would equal 350. And the second equation would become 1.75P minus 1.75W equals 210. Now you can use whatever method you'd like, but there is a method that's easiest. Which one's going to be the easiest here? Good, elimination. It's all set up. It's ready. It's just ripe for a variable to cancel. All I need to do is add those equations together. So if I add the equations together, I get 3.5p equals 560, and then divide both sides by 3.5. That gives me the speed of the plane is 160 miles an hour. I can plug it back in and get the speed of the wind is 40. So I need to make sure I use the units on my answer. The speed of the plane is 160 miles an hour, and the speed of the wind is 40 miles an hour. Hopefully we've set up enough examples for you to see more than you ever wanted to see with uniform motion, but I hope that it's enough to help you not only be able to get through your homework, but really understand it well so that you're prepared. And good luck on exam 2.